welcome to this demo of my project GRAIL. Now we all know that the parallel APIs are the state of the art for looking up data on the web for AI agents. And I believe combining them with video data on a graph based architecture can further enhance our queries and help us generate much more answers with much more context, which can help AI systems do well in tasks in general. So today I'm going to go over the architecture of my project and followed by an example of that I had run, and then I'll visualize some diagrams of what it actually does. So the architecture is pretty simple. The user gives me some query. What I do is I extract the main entity or the subject of the query. I use an LLM for that, and then followed by that I go through the graph building process. What is this graph building process? The graph building process queries the parallel API to get the schema that would parallel ingest API to get the schema that would help answer this question, followed by the task API for the answer. We use this answer and summarize it, and then we use the task API further to get key recent events about the entity. So for example, if our query is what are NVIDIA's latest partnerships, offerings, opportunities and challenges, we extract the seed entity NVIDIA, and then we run the task API, get what it can do, followed by recent event, which was the third quarter financial results, and then we use the YouTube API to get the videos for the recent event. We get transcripts for those videos and then use an LM to generate summaries on those transcripts. And then we use the text answer and the video answer combined with and create a context which is given to an LLM to summarize it, which will then be used to generate embedding for this node, right? So we keep doing that. We take the nodes, we generate embeddings for them, and then we build graphs. How do we build graphs? So from the combined context, we generate new entities related to the question. So like for NVIDIA, here we generated these 5 entities: OpenAI, Anthropic, AWS, Humane and Intel, based on the combined context of this recent event and the task API answer. And then we build a graph for which we repeat this context generation process. So to give you an image, this is the graph that was built finally. First it was run on NVIDIA, then all these nodes were added, then it was run on OpenAI and these related nodes were added, and finally this were the top 5 nodes selected: NVIDIA, OpenAI, GPT-5, Intel and AWS, right? Once we have the knowledge graph, we embed all the nodes as I told you, and then we run the PageRank algorithm using cosine similarity of the embeddings for the weight of the edges, and try to find the top ranked nodes. From these top ranked nodes, we select the top 5 and use their combined context to generate a comprehensive answer, right? So this was the overall structure. Let me show you what it generated for NVIDIA. So this was what we received from the task API. The query we were trying to answer was what are NVIDIA's latest partnerships, offerings, opportunities and challenges. The answer generated by the task API was related to the Blackwell class accelerators, telecom, automotive AI. It told a little bit about the partnerships with Nokia and ongoing alliances with others. Challenges, it told about Intel, AMD, custom AI chips and all of these. And then we can look at our comprehensive answer. This was the answer that GRAIL generated. We were able to get answers about the recent partnerships with OpenAI, Anthropic. We also were able to get information about the Blackwell family and many other things. So this is the basic architecture of the project I've built, and I think extracting data from videos and generating a knowledge graph based on textual and video based data is one of the fundamentals of how we'll be able to generate much better context for our AI agents. Thank you, and honestly loved working with the parallel AI API. It was awesome in helping me generate this project.